So, let me just go ahead and just tell you exactly what this is so that we're all on the same page. A proportion, because this question will be on the test, and I want to make sure it's on video. It'll say define proportion. I am simply looking for, it is two equivalent, equivalent, I think that's how you spell it. I don't know. Ratios. Okay, so that is that. No, you didn't.
No.
Okay. So, let's go on here. I want to do this question right here. Go ahead. You guys try it on your own paper. All right, so I went ahead and I filled in as you guys did. I did this for you. And I knew that my table, even though, like you guys said, this shouldn't be there, right? This bottom row, I didn't mean to put too many. Regardless, but people, fries, bacon, and cheese. That is what this is consisted of. And I know that the recipe that I make, it feeds 36 people. It feeds 36 people. Okay, so I gotta basically scale it down because I don't need it for 36. Sure, I could still make the recipe for 36 people, right? But I'm gonna have a ton of leftovers. I don't want that. I want to make the same recipe, but only for a lesser amount of people. Okay? And I don't want the recipe to taste different. If I just start changing it and saying, oh, I'll just throw in 8 bags of fries and 2 strips of bacon, it's not going to be the same taste, is it?
No.
Put that pen away. Okay? So, we have got to be able to scale here. Now, I'm watching you guys as I'm walking around, and I'm noticing a lot of people are saying, okay, what if I just wanted to make it for, like, just me? And you know what? You can do that. There's nothing the matter with doing that. But the one issue that I see is what if you get these small decimals that are like repeating forever and always? It's going to be hard to handle, trust me. So what I want you guys to get in the habit of is whenever you're scaling, I want this number right here to be the GCF. Come on. So the GCF. That is what I want you guys to see. The greatest common factor of where you are now and where you're going. No? So if you have to go over to the side and do your prime factorization trees, and you have to look for common factors and do all that, do it. Most of you were able just to be able to look at it and say, okay, what do they have in common? I know that they have what, Zach?
9.
No. 9's not a factor of 20.
Oh, yeah. No, wait.
4.
Yeah.
4 is a... 4, yep, could use 2, but you're also going to get decimals. Doesn't matter. You can get decimals. I'm not saying you can't.
I said 1.
But you can do 1, but guys, I want you to do it this way. It's going to make your life easier, trust me. If you think about a common factor, okay, a greatest common factor specifically is perfect. And then I say, what am I doing to my amount of people? I am dividing it by 9. If I'm taking my amount of people that this is made for, and I'm actually dividing it by 9 people, then wouldn't it make sense that I have to divide each ingredient by 9? Yes, so I got to do each ingredient. So I only need 1 bag of fries. 1 bag of fries. I only need 3 strips of bacon, which just doesn't seem like enough, but... And I'm going to need 2 of the cheese. Is that right? Okay, just chill, please. Then I'm going to have 2 of the bags of cheese. You guys see this? That will feed 4 people. Now, I look and I say, okay, well, what am I doing to my people to go from 4 people to 20 people? I'm multiplying by 5, right? So, I multiply by 5, so I got to do that to all my ingredients. I got to get 5 bags of fries. I got to get 15 strips of bacon. And I got to get 10 bags of cheese. You have got to use scaling on this. Shut that door, please. You got to scale. When I have these on the test, this is learning target 1. It says I can fill in missing values of tables. That's the learning target. So I'm not looking for, like I see some of you guys just simply going, okay, if I just take it, and I know the ratio is 36 people, I need 9 fries. I need to figure out what if I have 20 people. And then you're cross-multiplying and dividing, and you're figuring out the ratio of 20 people to the number of fries that you actually need. That's a fine way to check, but it won't be right on the test. I'm just going to tell you right now. Did you guys hear me?
Yeah.
It's not going to be right. You got to scale. Now, some of you are doing the unit rate. Well, what if I did one person? That's fine. But I'd rather you find a common factor. Now let's do 16. Okay, because I added that on here. Now we're going to figure out 16 people. So I'm not going to add to my table. I'll just put it here. I'm going to put 16 right here for a second. Is there any way to go from 20 to 16?
Yeah.
Dividing by a whole number, that is?
8.
Dividing by a whole number?
No.
No. We're not going to do that. So you would have to scale again. I would require the scaling to happen. I say, okay, so I could scale back to 4, right?
Yeah.
4. But look, I already got it. So look what I can do here, actually. I can just add 16 on here. Like this. 16. Come on.
Couldn't you just then multiply
That's what I'm going to do.
column by 4?
That's what I'm doing right now. I'm going to do it in a different color if my thing would work here.
Let's pretend that's 16.
Oh my gosh, okay, that's 16. And I know now, okay, what am I doing to go back from 4 to 16? I'm multiplying by 4, so that means 1 times 4 would be 4 fries. It's going to be 12 cheese.
This is like the
It's not quite 8.
This
It
is
equals
thing.
25.
Oh, no.
Alright, so as I was saying, let me rewrite this so we can actually see what I'm doing since my board's not wanting to work for some reason today. Maybe.
that part.
Okay, if I change it to 16 people here, well, you could scale back to 4, you could scale to 2, right? Actually, I'll just do that, just so you guys can see it. So let's just scale to 2 people. I know I'd be dividing by 10. Dividing by 10 here, that's 0.5. Dividing by 10 here, that's going to be, what is it, 1.5? Yeah. And then dividing by 10 here is 1. Then I can go to 16 and know that I'm multiplying by 8. And times 8, that's going to be 4.
Oh, 4. I think this.
1.5 times,
12.
is that right?
Yeah, and then 8.
12, you can't even read this, I'm sorry. And then 1, it would be 8. So, and then you can always check it with your proportions. Absolutely, I expect you to do that. Again, to check it with your proportions, you just do the original one. You say, okay, what if I had 36 people, and I know that for 36 people, I need 27 slices of bacon. Okay, so I need 27 slices of bacon. 27 slices of bacon. How much bacon will I need if I have only 16 people? Jeez. Oh my gosh. So, and then you can cross multiply and divide and check it that way.
What
Okay?
does that say?
167. Oh, that's
It says
16.
1 dash.
It's 6.
Okay, so this problem right here, obviously there's many different ways you could do it, right? The one way, look, I know, just look at me though, I'd rather you listen. The one way that you can do it, obviously, there's multiple ways. But the way I think you guys appreciate the most is just being able to just go ahead and cross multiply and divide. Look at that, that is awesome.
That is the
So you do 7 times 24, and then you divide by 2. Or the basic way is you could just say, okay, what am I doing to go from 2 to 24? I'm multiplying by 12.
Oh, no.
So that is going to, I know 7 times 12 is what?
84.
84. Yes. Woo!
That's a good score.
All right. Hey, that's just amazing stuff. So anyway, now let me think with me here for a second. If I put 84 in here, if I could, it'd be just awesome. Fantastic. Okay, so if I actually put 84 in there though, couldn't I just simplify these ratios to make sure that it gives me the same simplified ratio? That goes back to chapter 4. Remember? When the target said I can tell if two ratios are equivalent. Remember that from chapter 4? And you could do it 3 different ways. Remember? You could simplify them as fractions. You could, all fractions are division problems. You could divide them, turn them to a decimal in this case. Or you could do the unit rate, which I don't think many of you did that way. But you could, right?
Yeah.
So keep that in mind. Just to be sure, it might not be a bad thing to just go ahead and just check your ratios once you're done. Because you're saying 2 to 7 is the exact same thing as 24 to 84. That's what you're saying. Okay, this one here, this one's a little harder to see, so you may have to cross multiply and divide. What is the answer here? Is it 10?
Yeah.
Hey, look at that.
It's 10.
10. So you could go and you could simplify 10 thirteenths. 10 thirteenths. Okay? Or you could divide it, and I'll divide it right now just to make sure. I'll get my calculator out and just to be like certain here. So I'm going to take 10. I'm going to take 10 and I'm going to divide it by 13. turn to a decimal. That's 0.76923. Remember that. 0.76923. And now I'm going to do 70 divided by 91. And you can see it gives us the exact same regular number. Okay? Exact same number. So that's just a way to check it, just to be certain. This last one, what's the answer?
16.
16?
No. Yeah.
Let's do the same thing here. Let's check it just to be certain. Now, once again, in your calculators, you guys could use the ABC button and actually simplify it too. But since I don't have that capability on this computer calculator, I can just put it in. 16 divided by 35. That's going to equal 0.45714. Remember that. And then 96 divided by 210. That's the same answer, right?
Yeah. 5, 7.
0.45714. Yeah.
I always make sure.
Okay. All right. Let's go on here. Go ahead. Okay, so this problem right here. What should I start with? What have I preached to you guys forever that you need to start with?
Oh, physical.
Edge pieces. If you don't have edge pieces on your paper, that is not a good thing. I want you to use them. You guys got to trust me. It's in your best interest to start with your edge pieces.
Does that be on the test?
What? I would like it to be yes.
But if we don't.
Okay, what I need, I'm looking here and I'm reading. There are 3 boys out of 8 students. So I've learned 3 things, right?
Yes.
I've learned that there are,
3 boys.
I'm writing in white. There are 3 boys. I know that there are 8 total students. And since there's only boys or girls, I know that the remainder after the 3 boys must be all girls. So there are 5 girls. That's where we start. This is what's going to start our fake ratio, correct? And it's going to help us on A and B. Okay, so what is the ratio of boys to girls? It's just 3 to 5. 3:5. Okay, what is the ratio of girls to total? That's going to be 5 to 8. Pretty easy, right? 5 to 8. Okay, if there are 57 boys in physical education class, how many girls? You must show your proportion. So this is what I want. Remember, I'm not putting any numbers on there whatsoever. There are no numbers going on there yet. I'm going to get my labels on there. I'm going to figure out what it's asking for. Is it going to be asking for boys to girls to boys to total, girls to total? We don't know yet. Okay? So I go to the question and I say, okay, it says if there are 57 boys. I'm going to go ahead and just put 57 boys in that real ratio. Remember, the second ratio of a proportion is your real. That's what we've been saying with all this stuff, right? 57 boys. Now I look, how many are girls? So right here is going to be what I'm looking for, right? I don't know how many of them are girls. That's what I don't know. That's what we're trying to figure out. If there are 57, if there would be 57, what would the ratio be? 57 to what?
9.
Can you listen, please? Thank you. Now I got boys to girls, so I know my fake ratio is also going to have to be boys to girls. Now I look at my fake ratio, I look up to my edge pieces up here. And now I just put the ratio of whatever it is. I know that it is 3 to 5. If you do not have labels on the test, it will be wrong. It will be wrong. I repeat, it will be wrong. Okay? So now I look at it and I say, I don't really know what 3 times something is 57. Maybe you do, and I don't personally. But I do know, I think it's 19, but not sure. But you can obviously cross multiply here and then divide 3 and get your answer. And what is it?
95.
95 girls, which makes sense. Now, is there any way to check yourself on this?
Yeah.
95 divided by 3.
No. Remember, can't you do this? Couldn't you go into your calculator and say, okay, I know 3/5 is simplified, or 3 to 5. Right? And then simplify the other one, 5795. It better simplify to 3 to 5. Now, if you don't, like with my calculator, I can't simplify on it, but I can divide, right? 3, yep.
2.6.
3 divided by 5. Whoops, wrong thing. 3 divided by 5. Enter. 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 0.6. You guys see it?
Yeah.
0.6. Now let's check 57 over 95 because I know this is 95 right here. So let's do it. 57 divided by 95. It better equal what?
0.6.
0.6. It better equal 0.6. If it didn't, you've done something wrong.
No.
0.6. There you go. Last one, real quick. I go in here. And I say, okay, what information are they giving me for my real? What are they asking for? They are giving me a total. So that's either going to go here or here. Where does totals always go? Bottom, second term. So I'm going to put 96 total, and I'm asking how many of them are boys. Okay, so now I know my ratio is boys to total. Okay, and I go up to my fake ratio up there and I say, okay, the ratio is 3 to 8. Right, guys? 3 to 8. 8 times. I know 8 times 12 is 96, right? Is 8 times 12 96?
Yep.
Okay, so I need to do it up here. It's 24.
36.
Real quick.
Yes, it is 96.
Okay. And then I go to my.
34 boys. I thought it was 36. This is
Yeah, it's
36.
36.
Is it? I'm sorry. Yeah.
That's 2.
My bad. Oh, it's times 12, not times 8. That's what I did. I thought it was times 8. It's times 12. It is 36 boys. You need to be listening, please. I'm not done. Okay? And again, to check your work here, you could do one of two things. You could simplify these two ratios. You could divide them to get decimals. You could find the unit rate. There's many things, but there's no reason to miss them if you can check them. Okay, so make sure we're doing better with that. Okay, so this problem right here, 4 balls of wool make 8 knitted caps. Right there's your ratio, right? 4 balls of wool, 8 caps. Okay? How many balls of wool will Malcolm need if he wants to make 6 caps? Now, if this wasn't learning target number 1, if this had nothing to do with making a ratio table, wouldn't we just do the problem like this? Wouldn't we just say, okay, we need 4 balls of wool for 8 caps? I want to know how many balls of wool I'm going to need to make 6 caps. Wouldn't we just do it like this and cross multiply and divide? Is this a good way to check these answers?
Yeah.
Absolutely. Because you guys, I think, you're understanding lining up labels. You know this is going to be wool.
We could do cross
It's
multiply divide.
yes,
OMG.
but okay. Did you hear me from the beginning? Okay. You can't. Yes, to check. You can't. This is just a check method, okay? Now, if it doesn't have a table, it doesn't say make a table. You can do it this way. But I'm saying for this purpose, for what we're doing here, this is a ratio table, and you have to scale. Remember, you look at the 2 pieces of information that is given to you, and you say, what could I scale to? Some people said, I'm going to scale to 1. How many of you did that? How many people scaled to 1 and figured out how many balls of wool for 1 cap? Good. You did a unit rate. So you actually did a combination of learning target number 1 and learning target 5. Remember, 1 is doing missing values in a ratio table. Learning target 5 is solving for an unknown using unit rate. When I say unknown, do you guys know what I mean by that? I'm not sure I did a very good job teaching that. Do you guys know what I mean by unknown? Chris? No. It's whatever it's asking for. In this case, how many balls of wool will I need? That's the unknown. We don't know that. We don't know how many balls of wool we need for that many caps. Okay? So some of you used 1 here to scale. That's fine. So what are you doing to go from 8 to 1? I'm dividing by 8. So what do I need to do to my number of balls of wool? I need to divide by 8. So I need to do 4 divided by 8. That's going to give me 0.5 of a ball of wool. So I need a half of a ball of wool for 1 cap. Okay? Now I look and I say, okay, I need to know 6. So what would I do to 1 to make it become 6? Haley?
Divide by 3 or times 6.
1 to 6. 1 becoming 6.
You said it second. Sam, you said second.
Times 6.
Yep. No. 1 times 3 is 3. 1 times what is 6?
1 times 1 equals 6. How do you get from 1 to 6? Just say that. So yours is a little different. What do you get from 1 to 6? 1 times 1 equals 6. 1 times any number equals that. What number?
It's okay. We'll go back to you, Dominic.
Times 6.
Times 6. So if you're multiplying the number of caps by 6, wouldn't it make sense that we multiply the amount we need for 1 cap by 6? So we do the same thing here. Half times 6 would be 3. Now that's not the only way you could have done it. Let me give you another method. You could have done this method. This is the one I showed you guys. I said, let's scale to the greatest common factor, which is 2. I know to go from 8 to 2, I'm dividing by 4. So what do I need to do to my number of balls of wool? Divided by 4. So that means I need, if I go buy 1 ball of wool, how many caps can I make, Mackenzie? If I go buy 1 ball of wool, how many caps can I make? If I go buy 1 ball of wool, how many caps do I make? One ball of wool, you can make 2 caps. Or I could buy 4 balls of wool and I could make 8 caps. I could buy 1 ball of wool and make 2 caps. Now, Sydney, put that book away. What am I doing to go from 2 to 6? Yes, Haley. Timesing by 3. So what do I got to do to my number of balls of wool then, Casey? Times 3. You got it. So we get the same answer, don't we? Now let me do the method that Mackenzie chose, which I loved. Awesome. Awesome stuff right here. She actually did something where she scaled forward, didn't you? What number did you choose here? So you went to 24 here, right? She knew that the LCM of 8 and 6 was 24, which was amazing. She scaled forward. Those of you that chose 1 and 2, you scaled backwards. Okay? So she chose this and she knew, okay, I'm multiplying the number of caps by 3, so I need to multiply the amount of wool that I use by 3 as well. And I got 12. Then she knew, okay, to go from 24 to 6, that I could just... Are you ready to listen? I could divide by 4. So what do I need to do to my number of balls of wool? Divide by 4, and I get 3. We got 3 regardless of how we do it. But it's all about what did you do to the top, same to the bottom. It's just ratios. All these are ratios. 4 to 8, 12 to 24, 3 to 6 with equal signs in between them. That's all it is. It's just in table form. Okay? Let's go on to this next one now. Okay, so here's this problem. So we already put in all the information, the people, the fries, the bacon, the cheese, how much you need. And then what I've been trying to show you guys is that if you double the amount of people that you want to serve, you need to double all your ingredients. So you have double the amount, right? Doubling just means multiplying by 2. Now I saw some really good variations of this that you can use. The first one is, or what I'm trying to get you guys to do, I'm trying to get you to relate when we did greatest common factor back in chapter 2. That's what I'm really trying to get you to do. I should see no pencils in your hands. You should be all listening to me. Okay? Listen, listen, listen. I'm trying to get you to do the GCF. That's what I would love for you guys to really get a grasp on. That is the ultimate way to do this. It's the best way. Use the GCF. Now, as I've said to you guys, some of you don't, you guys, like Mr. Z and I, we know our math facts really well, so we can just look at it and tell that 4 is the GCF. You guys all can't do that yet. That's okay. Can you listen? You guys can't do that yet, and that's okay, but you know how to find GCF. Remember, we do the prime factorization, right? Then we stack the prime factorizations. Then we look for
Common factor.
we look for common factors. Nice. You look for common factors, not triples, not doubles, not singles. That's LCM. GCF is looking for common factors. So what do they have in common? They have a common 2, a common 2. What does that mean the GCF is?
2.
No. If you have 2 2's, you multiply whatever they have in common, remember. So it's 2 times 2. So I know the GCF of 36 and 20 is 4. Now it's all about determining what am I doing to 36 to make it become 4. This is where you guys are getting confused. When you are getting a factor of, you're picking a common factor, whether it's 2, whether it's 4. When you're picking that, what your guys' mistake is that you're thinking, okay, I'm dividing by 4. The common factor isn't what you're dividing by, It's the actual amount. I know how much I need of each ingredient if I'm serving 36 people. I want to figure out how many people or how many of each ingredient if I'm serving 20. And I know that 36 can become 4 by division, and I know 4 can become 20 by multiplication, because that's exactly what factors are. Okay? So, I know that I am dividing by 9 to get to that. Now, I want to talk about this for a second real quick, because some of you are struggling with this just a bit. If you don't know you don't know what you're dividing by, let's say. If you don't know that this is divided by 9, how can you check it? Well, one, you could look at your multiplication chart, right? You could just go to the 9, or not the 9, the 4, and then go over to 36 and then up. You guys are always welcome to use multiplication charts in your agenda during it. But what I'm trying to get you guys to see is that division, as I told you from chapter 3 in our division chapter, division is used for 2 things, right? But you always know the whole. It's all about finding a part. Remember? Hello?
Yes.
Can you quit doing that, please? If I said 3 times 4, that's just a part and a part, and it gives you a larger number. It gives you a whole amount. I have 3 rows of 4. Therefore, I have 12 total. It's a whole. That's multiplication. Multiplication and addition are used for finding the whole amounts. Okay? Division and subtraction are all about finding the parts when you're given a whole. Does that make sense?
Yes.
So, when you know 36 is the whole because you're trying to identify one, you know one factor, you're trying to identify the other factor. So to find the other factor, you can still use division. Okay, so if you don't know what you're dividing by, just do 36 divided by 4. That will give you that other factor. Does that make a little bit more sense? Because I think you guys are having a hard time. How do I know what I'm dividing by? Well, to figure out what you're dividing by, you divide the 2 numbers you do know, the whole and the part. Okay? So I knew I was dividing by 9 because I know this is 36 divided by 4 is 9. Okay? Which means 36 divided by 4 is 9. Doesn't that also mean that 36 divided by 9 is 4? Right? Okay? So, now I know that 4 people. I know that I'm dividing by 9. What would I be doing to go from 4 to 20 though? Yes? Times what?
5.
Times 5. Times 5. You guys got it. Remember, if you know, I'm trying to make the same recipe. If I had 4 people and I said, I'm just going to use 7 packs of fries, I'm just going to use 20 packs of bacon, I'm going to use 16 packs of cheese. Is my cheesy bacon fries or bacon cheesy fries going to taste the same? No, they're going to be different. It's going to be all messed up. We want it to be proportional. We want it to be the exact same taste and the exact same amount of each ingredient, whether I'm making it for 1 person or 100 people. I just want more of it, right? That's why we do the same to every ingredient. So I know that I'm dividing by 9 to go here. So I need to do that to my amount of fries. I'm only making it for 4 people. So now I know all I need is 1 pack of fries. 27, I'm dividing it by 9. I know that I only need 3 strips of bacon. 18 divided by 9, I know that I only need 2 bags of the Gorgonzola cheese, whatever it is. Gorgonzola, yes. Now I know that to go from 4 people to 20 people, I'm multiplying by 5. I'm making it 5 times more of it. 5 times more of it, right? So I need 5 times more of each ingredient. 1 times 5 is 5 bags of fries, 15 strips of bacon, and I need 10 bags of cheese. Does that make sense? Now for this little bonus part down here that I added on.
Is mine still right?
There are many ways you could do it.
Okay.
How many of you took this number right here and made it to 2?
Me.
Good if you did. You just got some decimals here you had to deal with, but that's okay. Decimals are fine. You guys know how to handle those. How many people went to 1? Good. You basically figured out, what if it's just me at home? I just want to make myself my famous bacon cheesy fries. And I don't want to share with anybody. So it's just me. I don't want to make it for 4 people because it's going to be way too much. And I'd probably sit there and eat the whole thing, and that isn't a good thing ever. Okay? Now, hold on. I want to get through this. Hold on. Okay, so I'm going to add on to this. Okay? Now I need to figure out, okay, I've figured out for 36 people, I figured out for 4 people, I figured it out for 20 people. I want to know, okay, I invited 7 of my friends over and I want to make these for them. So I only need it for 8 people. So is there any way to go from 20 to 8 evenly?
Yep.
There is?
Wait, no, they're not.
No, there's no way to go from 20 to 8. There's nothing I can divide by whole number wise that would get me to 8. Now, you could scale again. You could. Maybe some of you did. Maybe you scaled back to 1 and then to 8, or maybe you scaled to 2 and then to 8, or maybe you scaled to 4 and then to 8. But what I saw, and maybe some of you saw this as well, I said, now wait a minute. Why would I need to scale? Why would I need to scale this again when I've already got a factor of 8 right there? Do you guys see it? I already have a factor of 8. I already know how much it needed for me to actually go from, or I know how much I needed for 4 people. So I'm going to take this and I'm going to say, okay, well, what did I do to go from 4 people to 8 people? Yeah?
You times it divided by well,
I'm doubling it. 4 people and 8 people, I double the amount of people. So if I double the amount of people, doesn't that mean I just need to double the amount of ingredients, guys? So I needed 1 for 4 people, so now I need 2 for 8 people. I needed 6 of bacon for 8 people. I need 4 bags of cheese for 8 people. Does that make a little bit more sense now? Do we feel better about scaling and tables and those things now? Good. Go ahead and do these 3.
can I just put the answers? Not the whole problem.
Okay, now this is where we have got to start with our edge pieces. Some of you continually fight me on these edge pieces and I have no idea why. Because I promise you, it's going to give you the best chance to get everything right. I promise. Because it just organizes your thoughts. You guys always say story problems are the hardest because you don't know where to start, right? Right? That is a known fact about story problems, and I'll tell you, even me going into story problems that are kind of difficult, I get to looking at them, it's like, I don't even know where to start. So you try to put stuff together. Well, I'm giving you that starting point. You start with these edge pieces. And the edge pieces, remember, is just the information that is given. Okay? I know that there's a 5 to 12 ratio. What I'm trying to get you guys to see is that there are more than just 2 pieces of information. Sure, you are learning that there are 5 red, right? Obviously. You are obviously learning that there are 12 total marbles. But there's one other piece of information you guys got to get from it. Because there are only reds and blues in the bag. Because of that, I know that there has to be the remaining color has to be blue, right?
Yes.
So it's going to be 7 blues. Now, these A and B are easy. I can just look up to my edge pieces. Red to blue. That's going to be 5 to 7. Blue to total. 7 to 12. Okay? Now, this is where you guys need to listen. I know it's time to go. Just please bear with me. I'll go quick. You have to draw a proportion. Some of you are getting to this point, you're like, I don't know what to do. Okay. This is the strategy now. We make our proportion. Okay? We look at it. We say, what is the question asking? Because here's the problem. How many pieces of information do I have here?
3.
3. How many pieces of information do I need for a ratio?
3.
4.
2.
For a ratio?
2.
2. Only 2. Do you know which 2 you need yet?
Yeah.
No, you don't know which 2 you need. You gotta read and ask what the question's asking about, Zach. Turn around. Okay? It says, if there are actually 56 blue marbles, how many total are there? So I am comparing blue to total. So I know this is going to be blue, this is going to be total. Why did I put total on the bottom?
Because that's how many.
Because there's only such a thing as part to part
And
or part to whole. There's no such thing as a whole to part ratio. So I put my actuals in here. This is what I'm trying to figure out, right? Right there's exactly what I'm trying to figure out, correct?
Yeah.
Correct.
I see people packing up, and that's extremely rude. You need to knock it off, please. Listen to me. Now I'm going to transfer my labels. Because if I'm comparing blue to total there, in this ratio, it has to be the same. Or it's not going to be a proportion. They're not equal. Okay? So I go up to my edge pieces. I say, okay, what is my ratio of blue to total? it is 7 to 12, right? And then you can, from here, you can cross multiply and divide. You could just see that you're multiplying by 8, so you must multiply by 8 here. The answer is
72.
90,
84.
96.
96. Now, let's say you're here, guys. Now, let's say you're here, and you figured out that there are 96 total marbles, right? What I'm trying to get you guys to do now is just check it. Just do 7 ABC 12. That's simplified. 7 12 is simplified. 56 ABC 96. Make sure it gives you 7 to 12. Or divide them and get the decimal. Or, if you wanted to, do the unit rate of each one of those. But that's just going to be a check to make sure you guys are doing it correctly. Alright, so obviously on the formative, it wasn't Lucky Charms. We were talking about Captain Crunch though, right? That's what it was about. And it was Target and Kroger. Well, this is a very similar question. So if you can do it on the formative, if you didn't do it well on the formative, now's the time you need to practice it here. So do this tonight on the video. Alright? You know, normally there are two ways to figure out a unit rate. You could, in this case, since we're comparing money in ounces, you could do how much per ounce, or you could do how many ounces per dollar. Right? Does that make sense? Right? However, the question specifically says which one is offering the better deal per ounce. So I want to know which one am I paying less for 1 ounce. So when I saw that, I immediately knew that this is going to have to be what label needs to be in the second term. Ounces needs to be in the second term. And again, we start with our proportion. This thing. Okay? I knew that right here I had to make excuse me. I had to make ounces in the second term. Do you guys see that? You have to do it that way. If you don't, it's wrong. Remember, unit rate's always per 1. 1 has to be in the second term. So since it's per ounce, I knew that ounces got to be my second term. Ounces, 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 and ounces. Okay, and that means if ounces are in the bottom, money's going to be in the top. It's just a proportion, just like we just did. Okay, here we go. I'm going to do up here, this will be Walmart. Down here will be Meijer. Okay, at Walmart, I know I can get 20 ounces for $6.60. So there's my ratio. If you want to consider it a fake ratio, you could. $6.60 per 20 ounces. And I need to figure out how much I can get for 1 ounce, right? So some of you are still kind of struggling with this. You're going, I don't know whether I'm multiplying, I'm dividing. And if you don't know, let's say you don't know, and you're on the test. Because I get it. Some of you maybe struggle a little bit more with your understanding of multiplication and division. That's something I'm trying to work with you at on review sheets and things like that. You guys will get it, I promise. Can't you just cross multiply and divide here? Samantha. Can't you just cross multiply and divide? Sure. You can always cross multiply and divide. It's just unit rate. Most of you are aware that, okay, any number divided by itself is always going to result in 1. Right? 20 divided by 20 is going to be 1. So if you're dividing the amount of ounces by 20, doesn't it make sense that we have to divide the amount of money by 20 as well? Does anybody know what this is? 33 cents?
Yeah. That's supposed to be Walmart.
That's Meijer?
It's
Yeah, I know that's Walmart.
No. Oh, whoops. My bad.
That's Walmart.
Sorry. Okay, so that's Meijer. This is Walmart. So this is 33 cents. Okay, and then Meijer is $7.80 for 30 ounces. And I want to figure out how much 1 ounce is. Once again, you could just know that any number divided by itself is 1. So I'd be dividing by 30 divided by 30. Or you could cross multiply. You're getting the same thing. Do you guys see that? 1 times 780 is 780 divided by 30. You're doing the same process. Whether you're doing cross multiply and divide, or you're dividing by whatever's happening here. Regardless, when you do that, I think you get, 26 cents or something?
Yeah.
26 cents. So right here, if I'm somebody that's trying to save money, and you guys will understand, you don't right now, obviously, none of you guys do. But when you guys are adults, you understand that this goes a long way when you start looking for wanting to save the most money. Clearly, you guys want to purchase this from where? Meijer. You can get it for 26 cents rather than 33 cents. So how much less are you saving? Well, whenever you're trying to figure out how much more, how much less, how many more, anything like that, does anybody know what operation that means? What operation is that asking for, Durgay? Subtraction is always how many more. Okay? So how much are you saving? Well, you're going to have to take 33 cents and you're going to subtract 26 cents and you're going to get 0.07 cents. Now, this is not right, guys. That is not 7 cents. I feel like I've went on and on and on about that, and some of you are really sick of hearing it. I'll stop saying it when everybody starts understanding it, I promise. This is 70 cents. And I don't want you to use this either. That's just a big waste. You don't see that in the real world very much. Am I wrong about that, Mr. Z? I don't think I just going off of just being an adult, I guess, I've never seen it. I don't really understand what the point of it is. I wish this wasn't even in existence. Because I think this is why this is not very good with you guys. You know what I'm saying? So it's 0.07. This is 70 cents. You're clearly not saving 70 cents. You're saving 7 cents. Now, you guys didn't make that mistake because most of you probably did this in your calculator, which it gave you 0.07. Okay? You added? This is the hardest thing. Now, some people do it all the time. Now, I'm just going to show you how I would do this problem. Let's assume for a minute that this last sentence wasn't on there, okay? It's not there. That sentence is not there for a second. Let's talk about how you would solve it. Well, it'd be very easy, right? You would take 1,200 copies. That's your initial ratio there. And in 12 minutes, and then you're going to put copies over minutes, and then 18, and then you're going to... And then I'm going to cross multiply, and then I'm going to divide, right? That makes sense? That's a good way to check it. That's a good way to check your answer. Okay, if this last sentence on here was not there, then I would totally understand why you would do it this way. However, it is easier. But our learning target specifically says, learning target number 5 says, I can apply the concept of unit rate to determine an unknown. I'm not sure if you guys even know what I'm saying when I say that. And an unknown, guys, is just something we don't know. In this case, the unknown is how many papers it would copy in 18 minutes. That's the unknown. That's what we don't know. Okay? You can't do it like this since it says learning target 5. So you have to use unit rate. Where I think I failed you guys a little bit when I taught this, or well, it seems that way anyway, is I hear people saying the 3-line thingy.
What?
Is this the 3 thingy? I hear that all the time. And it drives me crazy. Because it's not scaling, no. It is just this. I mean, this is what you guys do. And I'm watching people just do this all the time. Molly, stop. It's not the 3-line thingy. It's not the 3-line thingy at all. And I heard it last year, and it drove me crazy, and it's this year. So it's not just, you guys aren't the first ones. This is something that students do. And we have got to correct this. Okay? The only reason I put 3 lines on it is to try to help you guys understand it. But I think that I ended up hurting you in the process because you guys just became robots, basically, that basically said, okay, I need to draw line equal sign line equal sign line. That's what it seems like. That's not the way you think about it. This learning target says, I need to find unit rate. I need to figure out how much per 1. That's what unit rate is. So we're going to set up one proportion like this. Now I'm going to tie all this together at the end, so just bear with me for a second. I know that this is my initial ratio, correct? Now, why would we find unit rate? Well, the reason we find unit rate in these situations is because if you can figure out how much one... It's like saying, okay, I know that one shirt... Let me write this up here. This isn't this problem, but just bear with me. I know that one shirt costs $6. Should probably write it the other way. But regardless, if it's a true unit rate, it's 6 shirts or $6 over 1. Regardless, you guys get my point. If I know that one shirt costs $6, if I want to buy 5 shirts, how can I figure out how much I'm spending? How much? Shh. Guys, you're not thinking. Please, get with me. What are you typing in your calculator right now? Stop. If I tell you that one shirt costs $6, and I want to buy 6 shirts. Did I say 6 or 5? 6 shirts. We'll say 6 shirts. Doesn't matter. How can I, if I'm sitting at the store and it says right there, one shirt costs $6, and I want to get 6 of them, how much am I going to spend? Vidya? You're multiplying by $6. That's the whole point of using unit rate. Okay? Does that make sense? And that's what I'm trying to get you guys to see. That's all this is. So let's say that the sign doesn't say that. Let's say it says that it is $12 for 3 shirts. Okay? And I say, I want to get 5 of them, because I only want to wear the 5 of my shirts that I have for Monday through Friday. Okay? I want to get 5 shirts. I don't know how to do this, because I know 3 costs $12, so then another 3, that'd be 6, that's $24. That's not what I want to know. Well, the best way to do it is to figure out, okay, I want to think, how much does it cost for just one individual shirt? And that's unit rate. That is unit rate, and you guys don't even realize you're doing that, I don't think. You're figuring out, okay, this is one shirt, and I know that if I'm dividing the number of shirts by 3, aren't I going to divide the amount of money by 3? $4 per shirt. Now, how many did I say I wanted to buy? 5, right? What am I doing to go from 1 shirt to 5 shirts? Times 5 times 5 is $20. Now, look what we just did. We just worked through this entire problem, right? We worked through the entire thing. We just did the 3-line thingy. But did I start with 3 lines? No, I worked through it. I understood. Okay, I set up one proportion right here, guys. Right here. This was the first proportion. The unit rate. There it is. Did you guys see it? That's the first one. I figured out how much one shirt was. Then I basically forgot about this one over here, and I made another proportion to find an unknown. So when you guys say the 3-line thingy, what you're doing is you're just doing 2 different proportions. The first one, you're finding the unit rate. The second one, you are finding the unknown. Does that make sense? So get away from this 3-line stuff. Understand what you're doing. So now, going back to this problem, let's think for a minute. If I had this machine, it's doing 1,200 copies in 18 minutes, or I'm sorry, 12 minutes. 12 minutes. I could also write it like this, right? 12 minutes for 1,200 copies. Now, what would make more sense here, guys? What would make more sense? To figure out how much time per copy, or how many copies per minute. I'm not saying makes sense in real life. I'm not saying that. I'm saying based on what information they gave us. Taylor? Per minute, right? Do you guys see why? Because I know that if I can figure out how many copies it is per minute, then I can just multiply it by 18 to figure out how many total copies I would get, right? If this question didn't say this and it said, instead it didn't have this question right here, and it said, I need to do 2,500 copies. How much time would it take? If it gave me 2,500 copies, if that's what I do, so let's say I knew I had 2,500 copies I needed to make. I need to know how much time I need to allot myself down in the copy room. Would I find the unit rate per copy or per minute? Hassinger? Per copy. Do you guys see that now? Because it's giving me, because once I figure out per copy, then I can just multiply by 2,500. Does that make a little more sense now? Okay. So, because I gave minutes, I want to figure out per minute. So I'm going to find the unit rate here. I'm going to figure out how many copies will that thing spit out in 1 minute. Which is 100. Yeah, 100. That's 100. 100 copies. That's 100. It's 100. It's a 0. Okay? Okay? Now I know that 100 copies in 1 minute. Now it's easy. Because I know that, see, there's my first proportion, right? There's my first one. I'm done with this one now. This one's gone. Now I'm going to make another proportion. So sure, you could rewrite it. You don't have to do the 3-line thingy. You don't have to do that. You could just leave this and say, okay, I've done my first unit rate proportion. Now I'm going to do this one. Right with the arrow. That isn't going to work. 100 copies in 1 minute. How many in 18 minutes? You guys see how that works? It's just 2 different proportions. This isn't 3 lines. That's not the point. Does that make a little bit more sense, guys? The answer ends up being 1,800 copies in 18 minutes. Do we understand?
Yes.
Do I ever want to hear the 3-line thingy again? No. It is proportions, but you're finding unit rate per whatever information they gave you to find the unknown. Okay? Let's go on to the next one. Here we go. A snowstorm dumped 18 inches in 12 hours. How many inches will it... Really? How many inches will it snow in 20 hours? Use unit rate to... Okay, so once again, here's my first ratio. I have 18 inches in 12 hours. Stop, please. Seriously. I have 18 inches in 12 hours. Now, the question's either going to give me the actual number of inches or an actual amount of hours, right? And it just depends on what it gives me. That's what I'm going to find the unit rate. If the question would have said, how many hours will it take to snow 40 inches, then I would want to find the unit rate per inch, right? But because it's giving me an actual number of hours, I want to figure out the unit rate per hour. So that means I know that hours must go on the bottom. So that's going to be 12 hours to 18 inches. And I need to figure out how many inches that is per hour, which is it 1.5, guys?
Yeah.
1.5 inches. That's just my unit rate. Now, you could just extend it and put it here if you wanted to, and then do it that way with another proportion. Or if you wanted to, I'll do it both ways. You could rewrite it 1.5 inches in 1 hour. Okay, well, how much would I snow in 20 hours? And that's where it's at, and you get 30 inches. How much would I snow? Yes. 20 hours. Shh. And this is 30 inches. So it doesn't matter how you do it, guys. You see that? You see how it doesn't matter?
Yeah.
So are we all away from the whole 3-line business stuff?
It's
Okay. All right. Shh. This right here is a 5-point question on the summative. It's straight on there. It's 5 points. You guys know that. It's 1 point for each unit price of the fruit. And then it's the 5th point is the one for the question over there to the right, okay? So it's on there. You guys saw it on a formative. Most of you did pretty well with it. Okay? Okay, but still, I want to make sure I go over every aspect. I want to give you guys every opportunity to do well on this test. Okay? So please, please, please listen. First off, I'm going to tell you right now, in order to even get these points right, you need a proportion for every one of these answers. Proportion, proportion, proportion. If you don't have a proportion, it's wrong. It's just that simple. Okay? Now, the other thing that would make it wrong, let's say I'm doing... Remember, I'll go over this real quick, even though I went over it several times now. Unit price means the price per unit, which means unit, in this case, would be orange. 1 orange. Per whatever. Per whatever the object is. Stop. Per the object. You guys got me on that? It's whatever it is. That's a unit price. If I was buying a big package of pens, and it was $5 for the pack of 4 pens, the unit price is how much does it cost for just one of those pens. That's the unit rate. So it's the cost per unit. Got me? Okay. So, $3.01 and 7 oranges. The way this is written right here, you guys could make this mistake. This is wrong, but I'm going to show you the mistake, because learning from mistakes sometimes is the best way to learn. 7 oranges for $3.01. I see people doing this, and it's wrong. And they go like this. Why is that incorrect? Yep.
Because the 1 always has to be on.
Second term. The per whatever you're finding it up, per ounce, per orange, per whatever. You have to make sure that per whatever is in the second term of the ratio. So, you got to do a little work here. This will be wrong. Guys, I won't accept it. I'm not accepting it. Got me?
Yeah.
You have to flip it over, and you have to put money on the top. So the first proportion here is 301 over 7 oranges. And I want to know the unit rate for how much does it cost per orange. Video, what is the answer here? 43 cents. So that would go right here. So the unit price for oranges is 43 cents. Okay, now I'm going to do 5 kiwis for $1.85. So $1.85 over 5 kiwis. By the way, if you don't have labels, it's wrong too. 1 kiwi, what's the answer here, Hassinger?
37 cents.
37 cents per unit, the price per unit per kiwi in this case. So it is 37 cents. And then for the plums, it's going to be $2.88 per 1 plum. And I need to know how much 1 plum costs. Somebody tell me. Breaker. What is it? 32 cents. So it's 32 cents. Okay, and then finally pears are $1.68, so 168. No, that's an L, plum, PL, because it's pear and
Oh,
plum.
I know, but you put 1 instead of 9.
My bad, sorry. Okay, so $1.68 for 3 pears. I want to know how much 1 pear is. It is, 56 cents. Jeez, the pears are expensive.
Yeah.
Jeez. Okay,
One
56
pear.
cents is 1 pear. So unit price is the price per the object, whatever the object is, one of the objects. Okay? That is 4 points right there. So, just to recap, just to make sure you guys heard me, because I don't want anybody getting mad at me when I count them wrong if you don't have it. You cannot just have that answer. You better have that answer along with that work right there. Got me? You better have this answer right here better come along with this work, and so on and so forth. You guys got me? Now, realistically, to answer the oh boy, whoops. That's not what I meant to do. To answer this question over here, you really don't need to do proportions. You could just multiply and add, which I'm fine with. I'm not going to require proportions on this part right here. Okay? But I'm going to show you how you could do it with proportions. It's very easy. I want to know 7 kiwis and oranges. So I'm going to do kiwis up here. I'm going to do oranges down here. Okay? I got it. Okay, I know that kiwis cost, the unit price was 37 cents. 37 cents per 1 kiwi. If I know how much 1 kiwi costs, then I can multiply by however many kiwis I want to buy. And I want to buy 7 of them. So how much does it cost for all those 7 kiwis? Hassinger? $2.59. Okay, then oranges the same way. I know that oranges are costing me 43 cents per 1 orange. So if I want to buy 12 oranges, I need to multiply by 12 to both the top and the bottom, yes?
That would be
$5.16. But notice this, what's that keyword? I was looking around Glassburn's classroom the other day, and he, on his wall, like if you're looking up at his board right there, if his board was there, on this wall right here, there's one that says word problem words. Do you guys know which one I'm talking about?
Yeah.
And it's got that word right there, total, is in there. What operation does total mean usually in a lot of cases? Add. Not always, but for the most part, when you have an amount, because we obviously didn't just add in the beginning, but you've got to add them together. If you just had this, what you have on here so far, if that's all you had, it's probably going to be wrong. And not probably, it is wrong. It's wrong. Because it wants to know the total price. You got to take the price of those 7 kiwis, and you got to take the price of those 12 oranges, and you got to add them together. When you add them together, what do you get?
$7.75.
775. Okay, hang on. Okay, $7.75. 5 points right there.